Hey mathematicians, it's Justin again. I'm so glad you're here. Mia and I are getting ready to bake treats for the annual bake sale. Check out our new cupcake recipe. You're right, Mia. Something does seem different about these numbers. That's because they're decimals. Let's see if we can figure out what these decimals mean so we don't mess up our cupcakes for the bake sale. By the end of today's lesson, you'll be able to read, represent, and determine the value of decimals to the tenths place. Have your guided notes ready, and let's get baking. Here's our first ingredient. What do you notice? This number has a dot in it. Numbers with dots are called decimals. Just like how a fraction is a piece or part of a whole, a decimal is a number that represents a piece or part of a whole with a decimal point. A decimal point is a dot that separates a whole number from its parts of a whole. Any digit in a number that's to the right of the decimal point has a value that's less than 1. But how much less than 1? We can use a place value chart to figure this out. We know that with whole numbers, if we start at the ones place, each place value increasing to the left is 10 times more than the previous place value. If moving one place to the left makes the value 10 times greater, what happens when we move one place to the right? Moving one place to the right means the value is 10 times less, and we're dividing by 10. If we check the cups of sugar, the ones place has a 0, meaning no whole numbers. The 5 is to the right of the decimal point, so it would go here in this place value. The first place value to the right of the decimal point is called the tenths place. Since we have a 5 in the tenths place, what do you think the value of this 5 is? The tenths place represents 1 divided by 10, or 1/10 of a whole. Since this digit is a 5, its value is 5/10, or 5/10, because it represents 5 pieces out of 10 equal parts of a whole. As we keep on using decimals, you'll need to know how to represent them in a few different ways. Let's try using a place value model. We know 1/10 can be broken down into 10 ones, so how many tenths do you think make up one whole? Pause the video here to record your thinking in your guided notes. You might have said 10 tenths make up one whole, and that's right. So we've got 5/10 of a cup of sugar to put in, but what if I wanted to show it in expanded form? Let's review what we know about expanded form with whole numbers to think about what it would look like with decimals. With a double-digit number that ends in a 0, like the number 50, we don't need to write the expanded form as 50 plus 0 because we already know 50 plus 0 is just 50. The same thing happens with 5/10. We don't need to write 0 plus 5/10 because the 0 in the ones place doesn't change the value. So we can just represent the expanded form like this: 0, decimal point 5. In words, we say 5/10 of a cup of sugar, just like the fraction. You might have heard people say 0.5 cups or half a cup before. As we start learning about decimals though, we're gonna practice reading them with their place value names. So we read this number as 5/10. All right, our next ingredient is salt. Start by checking the digits and determining their value. How much salt do we need for our cupcakes? 2/10 of a teaspoon. In words, this looks like 2/10. Using a place value model, we shade in 2 1/10 pieces because that shows 2/10 of the whole. Pause the video here to practice representing decimals in word form and with a place value model in your guided notes. Our first number has a 0 in the ones place and a 4 in the tens place. So the value is equal to 4/10. On the place value model, we shade in 4 1/10 pieces. Next, we have 0.3, which we read as 3/10 and show with 3 pieces colored in on our place value model. Do you notice a pattern when representing decimals that are less than 1 whole to the tenths? The value is the same as the number of tenths. This is always true when the only other digit is a 0 in the ones place. But we've got a few ingredients that have a digit other than 0 in the ones place too. Our next decimal ingredient is flour. What place is each digit in? The 1 is in the ones place and the 5 is in the tenths place. This number is greater than 1 because there's a digit greater than 0 to the left of the decimal point. This number has a whole number and some parts of a whole. So when we read the decimal point, we say and. We need 1 and 5/10 of a cup of flour. Notice how we read it differently than the last few numbers we saw. When we read this number, we say 4/10 because it only has parts of a whole. Back to the flour, we can also show this decimal in expanded form. When we say and, we write it as a plus sign, like this. First, we write a 1, and is the plus sign, then 0.5. 1 and 5/10. Decimals can be part of numbers of any size, though. For example, you could have 4,270,569 and 3/10. Whew. Even in huge numbers like this one, this place is always the tenths place, just like how the other places always stay the same. Try out this practice problem with numbers greater than 1. Pause the video here to practice representing decimals in word form and expanded form in your guided notes. To read this number, we start with the leftmost place value. So this number is read as 36,792 and 8/10. The 3 in the 10,000s place has a value of 30,000 plus 6,000 plus 700 plus 90 plus 2 plus the 8 in the tenths place, which has a value of 8/10. Awesome work today, bakers. So what have we learned today, besides the fact that every place matters when working with decimals? Well, now you know that when working with decimals, all digits to the right of the decimal point have a value of less than 1. A digit in the tenths place represents 1/10 of a whole. Decimals can be represented with digits, words, values, and visual models. Thanks for all your help today. Now that we know how to recognize, read, and describe the places of values of digits in numbers to the tenths, we can finish baking these cupcakes and get ready for our bake sale. Be sure to complete the practice questions and extension activities that go with this lesson to practice working with numbers to the tenths. And remember, mathematicians, in math, as in life, every effort adds to your success. I'll see you next time. Hey.